Can you hear me through the microphone? Microphone? Okay. Welcome tonight, everybody. This is the last Sustainable Energy, Sustainable Seminar, or Sustainable Homes Seminar for the 2014-2015 series. And we've been kind of experimenting with how we get the word out there. So I think we've got, like, other than our own internal email list, we've got, and Facebook outreach, we've got three other venues to get the word out. So we're getting people from everywhere, and that's great. So I appreciate y'all coming on this nice spring night. A little bit about the series. This is year 8, I believe. Josh and Steve here founded the series to help promote the word about sustainability in residential applications. Hi, welcome. And it has gone through many iterations, I'm sure. It's my second year involvement with it. The U.S. Green Building Council was asked to kind of run the logistics of it so Josh and Steve could focus on their real jobs, but they've still been heavily involved helping guide it and helping provide information and content for the series. So we thank them for basically making this thing fly for 8 years now. We also have a list of sponsors. Abby, if you click ahead. One back. Just in alphabetical order. A1 Heating, the Boise Weekly gives us a lot of deep discounts on their advertising. Building Energy Incorporated is energy verification, so like blower door testing and ways to confirm that your home is as tight and as efficient as it was meant to be built. Earthcraft Construction, a local builder that builds nice sustainable homes. Franklin Building Supply. Flying Cowboys is a design, build, and remodeling company. Gravitas Design. Next, please. The Green Remodeling, that's Josh's biz. That's the longtime founder and supporter. Idaho Power is one of our primary supporters, and we've got Scott Gates, a representative from the company here tonight to tell us about the net metering program, which, of course, is very tied to solar panels and how they work on residential applications. Johnson Brothers Windows and Doors. Osprey Building Performance is another building energy verifier and rater. Renewable Energy Solutions, that's Stephen Howe and his company that's going to be giving us the overview of residential solar photovoltaics. Solar Cascade is a solar provider. They're a company you would go to have a solar array designed and put on your home. The Integrated Design Lab is from the University of Idaho. They do energy efficiency and daylighting research and design services for projects around the area. And this is their space. They let us use this space for the series. And the U.S. Green Building Council Idaho chapter, that's us. And we've kind of run the back-end logistics this year. So wanted to we don't always give everybody a run through, but since this is the last one of the series, give everybody a shout out and thanks for your support. So tonight's topic is photovoltaics. And Stephen Howe for the Renewable Energy Solutions is going to give us an overview of the basics and how to get started in that for your residential applications. The building we are in, again, is the Integrated Design Lab. Their equipment and then the lab is this way, so we ask that you don't go through those doors. There's a bathroom this way down the hall, long ways down. Just keep making rights, basically. And Micah, did you get the door propped open? I blocked it open. So it's blocked open. There's a locked door, but it's open. Just leave it propped open as you go in and out. It's a 2-hour format. We'll do a break right at the top of the hour, 10 minutes or so. So that's the time you can go down there. But feel free to get up and move about. We've got snacks in the back. We've got a sign-in sheet that looks like it's making its way around. Make sure everybody's signed that. If you're not a sponsor, there's a attendance box there for paying your fee to pay for the snacks. And we're glad that y'all came on such a nice day. Looks like photovoltaics is a hot topic. So that's all I have. Does anybody have any questions before we get started? Okay, Stephen, I think it's all yours. Oh yeah, I'm sorry. Thank you, Scott. What we'll start off with is we had forgotten that we had Idaho Power had volunteered to come and tell us about their net metering program, so how you connect to the utility grid when you have a solar array on your home. And so we were reminded again today that that's happening, and we're glad that Scott can come. So he's going to just quickly overview what the program's all about, how it works, and then field questions before Stephen gets into his content. Can we get started? Please. And what I'll do is I'll have you wear this one, and I'll do the traveling mic, and that's just so the people online can hear. It doesn't amplify it.
Okay. Can you hear me okay? Well, welcome. I just found out today I was coming too, so this is kind of a joint thing. And what they originally said was, you know, if anybody has any questions on net metering. So I really didn't have anything prepared, which is probably good because I'd rattle on forever with it. But we've got a net metering program, and the definition of net metering is to offset part or all of your energy consumption. It's open to all rate classes. We started it in about 2002. And we changed it here about 2 years ago. And we had put in for about 6 different changes on it. The only one that resulted from it was we went to a kilowatt hour credit. So if you generate in a month more than you consume, your next month you get a credit, a kilowatt hour credit on the bill. Now the next month you can add to it or you can use that credit up. One of the other changes is you can transfer the credit, but there's a whole list of criteria that the meter it's going to has to meet. So it's kind of tough to transfer them. The PUC and the company where they were coming from on that is what they call right-sizing a system, not building a system that produces a whole lot more energy than what you use. We do have some people that maybe the house is buried in the trees and the shop or the garage or the barn is out in the sun. They both have their own meters. If they're a similar rate class, you can generate it on the barn, and then every January you get the opportunity to move that credit to the house and then work away at it. Kind of a manual deal. We just got through our first pass at this, and it was interesting. We now have about 600 net metering customers, and of those, 40 of them applied to transfer their credits. Only about 20 qualified for the transfer. You start looking at the other 20, some of them didn't have credits, some of them didn't have a meter to go to, it wasn't in their name, it was a different rate, so there was a lot of confusion about the whole process. We're trying to get better at it too. But if you're looking at putting a system on your house and I just looked at one today that I inspected on it. And so what she did is she is planning on producing about 50 to 75% of the energy the house uses. And then depending on what happens, she may add a few more panels and microinverters next year to get to more of it, but to stay under what she uses totally. Now you don't lose that credit, so if it does go around the whole year, you don't have any place for it to go. One of the options that we put out there was that you would forfeit your credit. Well, that got tossed out too, so the credit stays on that account. So you might have a better production year one year and more consumption the next year, and you can use it up. So it doesn't have to be just exact on it. Yeah?
Is your net metering 1-for-1?
Yes. In fact, we've kind of devalued the kilowatt hour. If you look at your summer bill, you've got a tiered rate. So your over 2,000 kilowatt hours is almost 11.5 cents. The 800 to 2,000 is about 9.5 to 10 cents. Under 800 is about 7.5 cents per kilowatt hour. So what we've said is if you go through the generation, especially through those expensive summer months, and you're creating a credit, we're just going to subtract that from the top of the bill at the next month, and then you're billed on the balance. You'll always have the service charge. But yeah, it's 1-for-1. We don't look at any of the tiers. Out of season, the rates are cheaper. So if you build up that credit, you'll probably, especially with solar, now wind and hydro and some of the others can generate it any time of the year. But with solar, if you generate it during the summer, typically they're going to use it up in the wintertime. It's primarily solar now. I've got probably 40 wind turbines hooked to us. Probably 35 of those are down. There's no replacement parts. There's nobody working on them. Some of these people have $100,000 invested in their wind turbine, and they're not working. It's just sad. But as solar costs have dropped, wind costs have increased. And if you take a good wind turbine or a good wind site and you put a 2-kilowatt wind turbine and a 2-kilowatt array at a good wind site here in southern Idaho, you're going to get about 50% more out of the solar. So for less money, more production, less maintenance, the whole shift recently has been towards solar with it. So out of 600, probably 550, 540 are solar customers. There's a limit for residential at 25 kilowatts and a limit for commercial at 100 kilowatts. If you say an average house is 1,050 kilowatt hours a month, I don't know who really uses that, but if you take our 550,000 residential customers and divide the generation into it, you get $1,050 a month as kind of that common middle ground. In town, that's probably close to it with gas heat and water heat. You get out of town where they're all electric with wells and that's low. But if you take $1,050 a month, it would take about an 8 kilowatt array to offset that on an annual basis. Yeah?
I was just curious, what classification is agricultural? Is it going to be based more on residential, or is it just depending on which meter you tie into?
Well, there is one separate ag rate, and it's a rate 24. And that's if it's pumping, if it's just pumping. And that can be a pivot, but if it's just in the irrigation part of it, then it's a rate 24. So if you go to trade credits, a 9, 24, and 19 can trade amongst themselves, large commercial, ag, or industrial. 1s and 7s are residential and small commercial. So the house could be a rate 1, the barn could be a rate 1 or a rate 7. And what pushes it from a 7 to a 9 is the consumption. If it goes above, I think it's 2,000 kilowatt hours, 3 months during the year, then it automatically gets bumped to a 9. The rate 24 typically is the lowest per kilowatt hour cost. The rate 7 is the highest. And then residential is right in the middle of it. It's a $100, flat $100 charge for us. We're trying to keep it at that because there's so many variables there. I mean, if I check like one today in Meridian that I did, that $100 does a pretty good job covering it. Well, when I went to Ketchum yesterday, or when I went to Jameson, Oregon the day before, or Salmon last week, not so much. So what we tried to do is just stick with the $100, and we're hoping that one fixed fee. And for that, you put in an application, and I've got copies if anybody's interested. You put in an application once you've decided on the equipment, but before you've purchased. Put in the application. It's a simple one-page application. You got to mail it in with a check for $100. You'll get a letter back saying that we received it and that they're going to send it to a planning engineer. And a planning engineer is going to take a look on the maps, not on site, but on maps at the transformer and the service line. And if it can handle the generation that you want to put on, you'll get a good to go letter back. Now recently, with the cost of solar coming down, I have had some homes put on some 25 kilowatt arrays. Big array for a house. Well, they've had to pay for transformer and service line upgrades. It's nice to know that early on instead of later. I'll get applications months after installations. Not to mention any names, Mr. Brueggemann, but it does happen. And you know, we're fine with that. You get a good to go letter on it. You install the system. There's a form online that's called a verification form. Once it's installed and inspected by the city or the state, just send us that, and that starts the clock on us to get the meter changed out and the rate changed on it. We get about 2 weeks to come out, do our inspection, put the plaques on, and then about another week to change out the meter. That whole process should take, if it's done correctly, about a month, depending again on where it's at. You know, if it's going to be in Blackfoot, the people out of Pocatello handle that, but the meters are reprogrammed in Boise, and I'm driving to Blackfoot. So it could be a little longer. Any questions? If I've got cards over here, if anybody needs a business card, or if you go to idahopower.com, middle of the screen is About Us on the right-hand side. You highlight that, and down at the bottom is Business to Business. You click on that, and it goes to Generator Interconnection. And Idaho and Oregon under 100 kilowatts is the net metering. The application's there, frequently asked questions, verification form, rate 84. If somebody's going to do something other than solar, there's also a Schedule 72 in there. It's kind of the technical document. That would be for like hydro or geothermal or something that doesn't use like a solar type inverter. All of that's available online though. Yes?
Is there anything changing over the next 5 years?
Well, the question was, is there anything changing in the next 5 years?
Yeah. It, you know, the beauty is if you tell us your system, apply for it, and we tell you you're good to go. You can even put in the system. If you never produce a kilowatt hour, there's no penalties. It's not like a power purchase agreement where you're committing to it for a set term. The downside to net metering is there's no contract. It's a rate tariff. It's a schedule. And if the company or somebody else petitions to the PUC to go in and change it, it's just like your residential rate 1. If it changes, nobody's bothered in. It changes for everybody. So to be worried about in the future, I've got hockey stick growth going right now. We did 40 to 50 applications a year for about the last 4 or 5 years. Last year I did 100, and the lady that works with me in there, Patty Best, she's got a bet going with me that by May 15th we'll be at that same last year's 100. We're about 80 right now. So, you know, we start doing 200, 300, 400, 500 a year. What utilities are looking at, and we brought it up in this rate case, is unbundling the rates. If somebody's a net zero producer, so they produce everything that they consume, they're really using the grid twice as much as what a typical customer that just pulls the power in is using. But they can get it down to where they're just paying a service charge. That service charge is about 1/4 of the cost of the billing and the meter and that kind of infrastructure on it. So even though none of those changes happen for us at this time, you're starting to see them go out to other utilities. And what I've been pushing within the utility, not that it makes a lot of difference, but what I've been pushing is if they get it fixed for all of Idaho's residential customers, then that's probably going to be the same thing for our net metering, because that underlying rate is still there. Whether you're a rate 1 residential, 7 small commercial, or not, that underlying rate that you started with is still there. The 84 just allows the credit to be on the bill. All the charges stay the same. For residential customers, charges change, then they would change for net metering. So if you bills could change, but hopefully they would change for everybody. So it'd be transparent whether you're on a rate 1 or a rate 84 rate 1. I don't know what else could be coming down. I think there's some things. They've got issues, and I don't want to get too far into this. They've got issues in California and Germany right now in high levels of penetration. The way these units work is they inject voltage. So house A turns on their system, power goes from maybe 240 volts to 242. When house B turns on his system, it goes from 242 to 244. Next one, 246. Well, it doesn't just raise that house, it raises the whole line. Everybody goes up together. Well, the way these protect the grid is they get to a certain level and they all shut off. They wait 5 minutes and they start back over again. So it just keeps progressing. The utilities are on the lines of, and so that's probably going to be something that you're going to see. California working on that now. The inverters to the utilities, especially on systems of certain sizes, they can actually really help us. These systems could be like a voltage regulator to us, help power quality in the lines if we let them. That's probably going to be the near term.
What's the reason for this recent acceleration of units being put online?
But the question was, what's the reason for the acceleration in rooftop units coming online?
I'm sorry, I don't think it
hit 100 units by this year. What's the reason for this growth?
Oh, you know, I think it's a number of different things. If you're looking in the ag industry, they can do a 25% REAP grant from USDA. You can do a 30% from the federal government. You can do an accelerated depreciation. And, you know, there may be other things that they can do in their marketing and that. So they can get the payoff. The Flicks down here said they got the payoff down to 7 years. So these systems are really, the one on the roof of Idaho Power has been producing now for 22 years. And yeah, it's starting to show its age. And as the power rates go up and the cost of the solar and the install and the system costs drop, I think more people are just looking at it as a way against hedging against future costs. There's a variety of reasons, but I think that's a big one.
We see a lot of retirement age wanting to go into it just to stabilize that energy price when they do retire. Seems to be a pretty big market for us.
One thing I've seen even more recently over the last 5 years too, with a lot more people going solar, to kind of add to that, is with the all the people that are out of area, so to speak, where they don't have a natural gas connection and they're using either straight electricity, propane, or diesel fuel for home heating purposes and things like that. A lot of times they change over to a high efficient electric system or geothermal, and they also use the solar panels to offset it because the cost difference in the amount of fuel consumption over the short term, usually the solar panels are sometimes pay for themselves in 3 years or less.
I know when I visit with customers out in the field, it's everything. You know, it used to be those people that didn't like us and wanted a way around us, or the early adopters, you know, that were trying something different and really getting into it. The lady today was probably a 73, 4-year-old housewife, and she just wanted the system. I mean, she grows her own flowers. She just wanted to do this. She's very efficient on her energy consumption, which I love. I love to see somebody that's already done what they can do on their energy efficiency side. But I like to tell them is it doesn't make a lot of sense to generate some of the most expensive energy in the world and, you know, waste it. It just doesn't make any sense to do it. So if you can get as conservative as you can get before you start doing the generation, which is what she's done. She's taken it as far down as where she thinks she can get, and this is the next step for her. Yes?
I guess I heard that in, as of 2016, the federal tax credit for solar is going to pay. I don't know if anyone knows about that. And
it's due.
I wondered if that might be spurring people to say, oh, I've been thinking about this for a lot of years. I better do it while there's still a tax credit available.
You know, and the jury is out on how much that will impact in Las Vegas this year. And what the industry thinks is it'll be a hiccup. I'm sorry, I'm thinking you do a 30% increase, 20% increase on system costs. Now, as prices continue to come down on solar, where they get more competitive, and the utility, maybe a year or two it picks back up again. But it's been set to go from 30% to 10% in 2016. And I think that's going to be significant, enough that some of the dealers in the area are starting to focus on commercial installations because they think it's going to have more of a buffer from that. There's more things you can do on a commercial. But yeah, that could definitely be doing it. Anything else? I'm good. Gary?
Two people who have really helped promote solar are named Janet Yellen and let's see, the other Federal Reserve guy, Ben Bernanke. Solar pays a lot better than past book savings. That's not much saying much, but what I put my money.
Very true. Very true. All right. Well, thank you.
And we'll turn it over to Stephen now, who was going to give the content on the intro basics to solar photovoltaics for residential applications.
Okay, yeah, so introduction to PV systems. Well, thanks, Scott, for that. And we also have Dave Brueggemann here, who's a photovoltaic system installer. Just absolutely wealth of information. So we'll try to point some questions to Dave as well. This is a house in Portland, Oregon. Array of polycrystalline photovoltaic modules, and it is also a passive solar house. Take a good look at that picture, and you can see a shadow that's falling across the solar arrays. And that's important because when solar panels are put into strings, the shadow will affect this entire string of solar panels, and then this shadow from this tree will affect this string, assuming these are two strings. Okay, sustainable basically is conservation plus renewable. Those two are, they play together. Here's what we want to avoid. This is a picture of the Gulf. This is oil and water. This is kind of like what we don't want to happen. Okay, photovoltaic system characteristic. It's a local production of electricity, rapidly decreasing module costs, right around $1 a watt now. Worldwide demand, competition, and economies of scale enable this progressively lower cost. There's about a 6% per year reduction in residential installed cost. High capital cost drives energy conservation. Even though these costs are coming down quickly, it's still an expensive proposition to lay out the money you need for photovoltaic panels. So that drives people quite largely to figure out how they can conserve. So those two play together. It's a technology with a low embodied energy. It takes energy to produce energy, but photovoltaics, it turns out, it takes a relatively small amount of energy to make the PV panels and the rest of the system. Grid-tied systems can annualize solar resource, using the grid as an energy bank. That's net metering, where you're basically banking energy and then withdrawing energy when you need it. And as much as this does cause problems for the power company, because they've got to do a lot of load balancing and that sort of stuff, it is a boon to consumers because they don't have to put in big battery banks. If you were trying to do this with big battery banks, then it would be much more expensive. Sort of as a side note, Tesla is likely to introduce in April 24 a battery system for the home to try to amortize and get scale with respect to battery production. So we'll look forward to seeing what that looks like. Beyond net zero. So beyond net zero, which is you're able to supply as much energy as you use, is supplying energy for your car. So that's sort of one more step. Okay, here is a net zero building that it's a home, and it's in Cuna, and there's a lot of solar panels on this house. This guy has a well, and it's a relatively deep well, so he's got to produce energy for a well. He also has a shop, which he's got a welder in. So he's got a couple of big energy uses there. He has solar hot water. It's not shown here, but this again incorporates passive solar design. You can see the windows, and he's got a concrete floor and then a brick interior wall. So he's using thermal mass and the right size windows, and then a fairly good size photovoltaic array, and then solar hot water. So he's very close to net zero. Yeah.
Can you remind us the passive solar glazing to thermal mass?
Oh boy, I wish I could. That's from notes, but yeah, basically the idea with passive solar and thermal mass is if you don't have thermal mass and have these big windows, the house will swing. You'll get very hot and then very cold because you get a lot of energy that you can't store when the sun's shining, and then at night that energy would just escape through big windows, and so the right amount of glazing and the right amount of thermal mass, that's critical. We didn't do a passive solar class this year. We'll probably do one next year. Okay, so here's the plummeting cost of PV. I mean, the photovoltaics came from the space program, essentially. Bell Labs space program, and they were the early drivers. And then the next generation was probably the off-grid folks, the backcountry folks drove some of the demand for it. You can see here in 1980, we're approaching $25 a watt. That's for a module price, not a complete system price. And down here, we're getting in 2009, you're getting to about $3 a watt, maybe $2.50. If you look at the price per watt a module sold now, you're easily in between $1.20 and $1, maybe a little lower if you get volume or there's a factor. I don't know, Dave, what are you paying for modules right now?
Well,
It depends. It depends. Okay. 75 to $1. Okay. So we're in, we're kind of in this region. But if you look at the worldwide installed capacity, now this isn't the per year production, this is the entire installed base, okay? A couple of things stand out. First, there's exponential growth in the installed base, and that's because it's cumulative, okay? That's what you would kind of expect. But if you look year over year at the installed base, it's not quite doubling, but it's going up about 30% per year. That's the installed base. Second thing that jumps out at you is if you do the color chart, is that Germany is probably the number one, they have the largest installed base. Next to that, which surprised me, was Italy, and then comes China and Japan and Czechoslovakia and India and, United States. That's not to say the United States isn't, the United States I think is here, so I think that's just where they put them in. So it looks like maybe we're number 3. ROE is rest of the world, is ROW, and ROE is rest of Europe. So there's something called Swanson's Law, which is similar to Moore's Law in electronics. Swanson's Law says the cost of producing PV modules decreases by 20% for each doubling of global PV manufacturing capability. So PV is all about scale. As much as electronics is about miniaturization, PV is about scale in terms of being able to reduce the cost, plus competition. Okay, here's worldwide PV production. You can see production in 2011 was of modules was just a little shy of 40 gigawatts. And in 2016, we're getting close to 65 gigawatts. So, the production of this is it's actually exceeding the installations. So over the past few years, there have been real pressure on PV module prices because there's been so much installed capacity that there's been more ability to make PVs than there is the number of people doing the installation. So that's driven prices down, and it's been a good thing. So this business is a tough business if you're a PV module supplier, but if you're a homeowner or an installer or a utility guy, this is great. Okay, yeah.
As far as like global usage of electricity, what percentage, and is that percentage increasing or decreasing as far as global production?
Yeah, I don't know relative. It's the primary thing about solar is the growth rate. The absolute numbers are not as impressive as the growth rate of solar. And so you look at that almost any new technology. You're not looking at how much of the market it has. You're looking at how quickly the technology is evolving and how quickly the price is coming down. So it's that growth rate you're looking at, not the overall, not basically the penetration. Okay, so basics. Power is voltage times current. This will become important later. The two characteristics of a PV array in the sun is its voltage and its current. The voltage, voltage is kind of like a turn-on voltage. The voltage doesn't change except for, perhaps doesn't change much except for temperature. It is temperature sensitive. And the current, that's directly proportional to how much sunshine is falling on the panel. Watts is volts times amps. Power is voltage times amps, and energy is power times time. So power is watts or kilowatts. Energy is kilowatt hours. So sometimes you get confused on those two. Okay, I promised myself to install a lot of pictures. These are frameless PV modules that are up on a deck. So there's beginning to be very interesting architectural uses of PV. And so I'm going to show those as time goes on. But these are Lumos frameless PV modules that let sort of filtered light go into a space. And so it doesn't have to be just a roof, you know. There are very many other places that people are putting PV. Okay, PV system characteristics. Grid tied is easier and less expensive than standalone, both because there's no batteries and because there's net meter. A lot of folks say, well, I want to have a battery standalone system, and you know, I have to sort of tell them, well, it's a lot more expensive. When the grid goes down, so does the grid-tied PV system. That's a disappointment to some folks. The inverters on a grid-tied system look at the grid and provide power that's matched both in voltage and phase. So good quality power is supplied by the PV array to the grid. And when the grid isn't there because of some power outage, even though you've got lots of PV panels, you're not generating for your home PV, you're not generating electricity unless you've got a special system. PV can require a lot of roof area. That's because of the relatively low efficiency of PV compared to solar thermal or passive solar. Reliable with low maintenance costs. Boy, that really differentiates PV from solar hot water. Solar hot water there's considerable maintenance. So long-term investment, 25 years. Technology is changing rapidly. I'd be remiss without reminding people that PV voltages and currents can kill you. So don't, be careful what you do. Yeah.
I wonder if Scott would weigh in on the connection between PV voltages can kill you and why the grid tied system goes down when the power goes down. I've been told that line protection is part of the deal there, and maybe you can tell us what that. Why does the grid tied system go down?
Why do the systems go down? The inverters only know how to produce the on-grid, or the grid-dependent ones only know how to produce their energy based on what the grid is doing. So they get their voltage and frequency and everything from the grid. And so if the grid goes away, they just shut down immediately. Now, from our standpoint, that's the most important function of that inverter, is protecting us and our people to keep it from coming back on the lines. Whereas from a consumer standpoint, the most important thing is converting the DC to AC. But that's really what set net metering off, was they came out with UL standards for the grid protection in it. And so there's a whole list of parameters in there that the inverter has to meet.
So it's both protecting the power quality on the grid and the people that would be working on the grid if it goes down on their time.
Right, right.
Okay.
You can see that it's got solar hot water, and he set aside space for PV panels. So new homes, if you're not planning about doing a new home and you're looking at the price of PV, you're not quite ready to do it yet, but you think you'll do it in the future, keeping in mind that the tax credit rules may change in 2017. You can set aside. Now, the other reason I showed this picture was, unfortunately, this guy has got a big garage, and he could have sloped it in a variety of ways, and if he had just sloped it in a little different direction, it would have been a lot better for PV. So this again is a passive solar house combined with solar hot water and with space for, but not yet implementing photovoltaics. Okay, so what are the rules of thumb? What are the attributes of PV panels? So the first one, and the most important one, I guess, is the sun. The sun will give you 1,000 watts per square meter, and that's all you get. You don't get any more than that. So it's what you do with it after that. And that 1,000 watts per square meter, or 1,000 watt hours, well, for 1 watt hour, that's called a peak sun hour. And it is a construct that says if the sun was shining perpendicular right at clear sky panel, how much would it generate in an hour? And it generates 1,000 watt hours. Okay, so off angle, the sun isn't, sun very rarely hits the PV panel absolutely at a 90-degree angle. Most of the time, it's off at some point. So you convert the hours that it's off into an equivalent directly hitting the panel number. So that's what a peak sun hour. So you might have 8 hours in the day where the sun is hitting the panels, but maybe you only get 5 peak sun hours because a lot of the time the sun is at an angle to these panels. So it isn't producing that whole amount. Okay, we get about 5.2 average angle peak hours per day in Boise. So if you took the whole year and you said, okay, on average, what do I get hitting the panel? And if there's no trees and no shadows and all that sort of thing, but accounting for weather and accounting for the changes in the sun angle, you get about 5.2 peak sun hours per day. And so this is how you do these annual calculations. The maximum PV module efficiency, the most ones I've seen are about 19. These are the sun power modules. They may be a little bit more. Again, I'm going to defer to Dave here. Have you seen more than 19?
Well, they have some under 20.
But you don't want to pay for them, so they're just more expensive. Yeah, okay.
Most of the ones we put in today are
15, yeah, lower than this. So this is, I had put this on, it's pretty much, so you compare this to the nominal efficiency of a solar hot water panel. Now, solar hot water panels produce hot water. PV panels produce electricity. And it's sort of like, it is very much apples and oranges. Electricity is a hell of a lot more useful than hot water. But solar hot water panel will produce hot water at about a 72, 73% efficiency. I don't know. Conversion rate of an internal combustion energy. Yeah.
about 42%.
42%. Okay. So we've got some system efficiency, some derating, some temperature, some inverters, some aging loss. So maximum system efficiency is about 14%. Now, PV panels are rated as capacity in kilowatts, and they're rated as so-called nameplate capacity. That means they're rated in terms of pretty much absolute perfection in terms of what they're able to produce. So if you have a 3 kilowatt system, it would be highly unlikely that you ever would get 3 kilowatts out of it because of these various deratings and stuff like that. Nevertheless, that's how systems are rated. And it's a relatively simple, straightforward way of doing it. You can add up the wattage, the rated wattage of each of the panels. You add them all up and you get, some rating of or some capacity. Daily production is kilowatt hours, and annual production is megawatt hours. And roof areas are between 10 and 15 peak watts per square foot. So this is another picture. This is in St. Switzerland. And if you look carefully, you can find PV panels along a cog railway. And they're right here. Right along this cog railway are some PV panels. More rules of thumb. The installed cost is between $3 and $5 per watt. You may want to correct me on that one, Dave. Yes, anybody got them for 3? That's 3 to 4. Okay. All right, but under 4. Under 4. Have you gotten any under about 3, or is that too low? 3.5. 3.5. Okay. All right.
On residential. You can approach the way on commercial.
Okay. All right. Smaller systems have higher dollars per watt, so if you're only putting up a few panels, then the costs are going to be higher. There's national trends in the Lawrence Berkeley labs, which is interesting, but they're about 2 years old by the time they come out. So there is a 30% federal investment tax credit. You have to have taxable income. You have to have enough taxable income to qualify for that credit. So that's on some retired folks, they don't, and so that's a problem. There's 100% tax deduction spread over 4 years. I just talked to an older couple, 2 school teachers, and I don't think they would qualify for either one of these. They're in their 80s, and they just don't make enough money. Yeah?
Federal tax credit over 2 years.
I don't believe so. I think you have to take it as 1 year. I haven't seen it ever done.
It's a general tax credit, yes.
Oh, you can? Okay, all right. I stand corrected then. Yeah.
You go back 1 year, actually over 20. Well, no, only 2, because you only do it at the end of the tax credit.
Okay, so you could spread it over 2 years if you wanted to. Yeah.
this is a question that maybe Scott is in a position to answer. You mentioned essentially the subsidies that are making solar panels attractive right now, but also the declining cost of the panels. At what point in the near future or the future do we hit this point where the technology costs a low enough amount that the subsidies go away, in your opinion?
I think a lot of those subsidies are going away now. The way some of these subsidies were structured, they couldn't keep up with the rapid drop of solar. And so in some areas they were subsidizing almost 100% of the cost of the system because the system cost was dropping down quicker than what, like Germany had rates that they were going to drop the subsidy on, and lots of them did, but nobody anticipated the drop of module prices. So I think a lot of the subsidies you can see back off on. That's a good question, because if the tax breaks go away and the cost of the system comes up, we're already starting to see module prices come up just a little tiny bit. So whether we have hit the bottom on module prices as the glut's used up, that's the kind of stuff that remains to be seen. Yes.
So for an example, a 6 kilowatt system at $4 an installed watt would be 24,000 before incentives and about 15,000 after incentives. So you see this incentive structure still plays a major role in getting the cost. And it's got about a 25-year design life, but as Scott said, the ones in Idaho Power are something over 20 years, and they're still going, and will go for a few more yet. Okay, so here's a close-up of that cog rail system. So you see the PV panels right along the cog rail. I saw, a very large number of unique uses of PV panels when I was in Europe 2 years ago. Okay, so now we're switching over to try to figure out what the demand is. So this is my house, and this is information from Idaho Power, just from my Idaho Power bill. And they have a nice little statistic on that, which says, what is your daily kilowatt hours usage that last month and the month before and the month before that? And they do it throughout the year. So I started off here on this blue line here, and then I lost a couple of kids because they went away to college, so that's kind of cheating. And then I got this black line, and I just kept at it. This big hump in the middle is air conditioning load. And the wonderful thing about PV is that it is pretty well matched to the air conditioning load. So that's a nice feature. It doesn't happen with wind. And it really is fortuitous that you get a matching of the load. For instance, on passive solar, which you're using primarily for space heating, that's the opposite. I mean, where you want it the most, which is in the wintertime, you have it the least because here you invert. But in the case of electricity and air conditioning, you get a lot of gain in these summer months right at the same time. People are both air conditioning and agriculture is irrigating. So it's a good match. Time of day, I don't know, but in terms of just, that day. Okay, so my goal was to get down to about 15 kilowatt hours per day, and 15 or 16 kilowatt hours a day. Then I could calculate how big my array had to be. So here's how at a tilt, this is a 43-degree tilt, so it's a pretty high tilt angle. And it shows the solar gain in peak sun hours, including the weather, as a function of that. You see in December, you only get about 3 peak sun hours with this high tilt. When you go into June, you're up around 7 peak sun hours. And the lumpiness in the curve is because these months you get less sun because it's the springtime. And of course in the fall you get really great sun here because you get lots of clear days in August, September, October. So here figuring 5 average peak sun hours for Boise and a 75% system efficiency and a 4 kilowatt DC nameplate system. and you generate about 15 kilowatt hours of average daily production. So what does that mean in terms of modules? Well, using 200 watt modules, you don't use 200 watt modules anymore. It's, like 240, 270. I don't know what the latest one you installed was. 280, okay. So this module size, the modules are a lot higher than that now. This is an old slide. But anyway, at 200 watt modules, it requires modules. And it requires, you can figure out how many square feet you need. And for this particular design, it would be 2 rows of 10 modules each, or 3 rows of 7 modules each. This is another net zero house. This is a St. Jude house. I think Dave you did this installation, I think. Is that right? And I think there's panels here. Are these also panels as well here?
Yeah.
Yeah. And what were these? 3 separate strings? Is that what it was? And 3 inverters or? 2 inverters. Okay. Here you see the solar hot water. These are tube collectors here. And so the St. Jude house was designed to be a net zero house. So it gives you some idea if you've done the envelope to minimize the energy gain or loss in the summer or winter. Yeah.
Quick define net zero.
Yeah, net zero means that you're producing on an annual basis as much energy as you consume. And that's total energy, not just electrical energy. You could be net zero electric, which would mean that you would produce as much electrical power or energy as you consume in a year. But in these particular houses, it's total energy. So, yes?
So the houses that have separate solar hot water heaters, recommended that you have a solar hot water heater and a solar array?
So far, yes, but it's getting close. It's getting pretty darn close. And the advantage of PV for a solar water heater is that it scales much better. If you were a family of 2 and did comparison of PV generating electricity and then converting it to hot water versus just having a solar hot water system, the PV would win because you wouldn't have to have as much. If you have a family of 5, then it's a much more difficult case because 5 is a sort of a sweet spot for solar hot water. It's much nicer. And if you didn't have a lot of roof area, because solar hot water is more efficient in terms of roof area, you require quite a bit of roof area to have photovoltaics and then turn electricity into hot water. So
overall payback is better with the combination.
Yeah, yeah. So that's a long-winded way of saying it depends. Yeah.
One other thing that does play into that too is typically you have to have, if you are using electricity as a fuel source, you'll be back to a straight resistive load for an electrical hot water heater, unless you go with a heat pump water heater. Or you have to have gas or propane or something else as a source for your hot water. Is where the offset on the cost is pretty good.
Yeah, if you use a combination of photovoltaic panels to generate the electric power plus a heat pump that is an air source heat pump that generates hot water, then the capital costs are both the PV array and the tank and the heat pump. So you have to figure all those costs in to say, well, is that better than just straight solar hot water or photovoltaics going into a resistance heating? There's a bunch of different ways of slicing it. So you sort of have to kind of do some analysis, try to figure that out. But in general, if you have a small number of people, like 1 or 2, then it's going to favor the PV. If you've got a large family, it's going to favor the solar hot water. Yeah.
So when we talk about in the winter electric usage on a home that's solar powered, does that include heating the home, or is that assuming still like a natural gas furnace?
They're attempting to use to generate as they use natural gas.
Okay, thank you.
Okay, so installed cost of $4 a watt, 16K. Cost after cost is a little under 7 cents a kilowatt hour. So you can see that over 25 years at $4 a watt installed, that you're getting a slightly better, if you're willing to invest for 25 years, a slightly better cost than what you pay now for power. But it's just now with incentives, being a little less expensive than power from the utility. Yeah.
What happens to the panels over 25 years? Do they lose their efficiency?
Yeah, usually they lose what do we figure? About 1%, 0.5% per year. So, there's soiling, there's a little loss of efficiency. I don't know what your experience with Idaho Power panels were. Did you know that at all?
Those were kind of hard to do because they were an older hand-built panel.
Okay, all right.
Their efficiency started lower. Being rated quicker than what we see now.
Right. So there is some degradation, but half a. Depends upon the technology. If it's monocrystalline silicon wafers, the answer is yes. If it's multicrystalline, it's not as good, but it's pretty darn good. If you were talking about the other technologies, which are thin film silicon, there's less data on that. They're relying more on accelerated testing, but there's still beginning to be quite a bit of history. Yeah.
Since we're talking about their lifespan, let's talk about the recycling of them. I know there's silver in the tracing, and there's silicon crystals in the production cells. Can they both be recycled? And there's glass, there's aluminum frames. How are they recycled?
We are not. We really consider them lifetime. They're going to produce less, but they're still producing.
No, but I mean, I guess the question is he asking, is there a mechanism for recycling built in yet?
Recycling.
Right.
There is no
method
to recycle.
So not yet, my guess is that.
So in practice, everyone just leaves them on. Let's keep
so far.
diminished.
But the first one I installed in '76, it's still working good.
So there's a 25-year life, but that's the manufacturer saying that's a life. The actual life is longer. So
unless they get damaged by hail or whatever, they're still going.
And there isn't much of that. Yeah.
Are they more efficient if you clean them? I mean, I'm assuming
they are. They are. They're. No. The problem with the cleaning is you scratch them too.
Well, I tell you, our biggest problem we found out. Clean them is people want to drag their hose out and spray them off.
Mm-hmm.
You've got a far bigger problem with water spots that you get to order up.
Okay, so here's a nice house. I see houses like this with great solar roof, and that's all I can do to not knock on the door and tell them, hey, you got a great roof. Okay, solar photovoltaic systems. There's basically these kind. There's grid tied, which I'm going to almost exclusively talk about. There's standalone, also known as off-grid systems, and the backup then is batteries. The challenges here are batteries are expensive. They don't last particularly long, and you've got to include as many batteries as what's so-called days of autonomy. And in this area, we get this fog, this inversion that lasts for a week, 2 weeks, 3 weeks. And so it's a really tough to design for this worst case with these standalone systems.
Well, there's no standalone system without backup.
Well, there you go. So you put in a backup generator. So grid tied with emergency battery backup, that's another way of doing it. Or as you said, you'd use a generator. Renewable energy hybrid systems with wind, microhydro generators, etc. That's where I guess that one falls in. Okay, so I won't go through this whole system diagram, but this is a layout for string inverters. And you can think of photovoltaic cells like batteries in the sense that the voltages add. When you string them all together, the voltages of each one of the panels add up. And all of this voltage is DC. So this array gets, it is the sum of the DC voltages of all of these panels. And then this array is a sum, runs at the same voltage. And these three panels provide current. And the current you can think of, well, kind of like water, simplistically. And they combine through this combiner box through a DC disconnect and into this inverter, through an AC disconnect and onto the service. So the inverter's job is to take DC voltage up to 600 volts DC. That's a scary thought. And convert it to AC. But not just convert it to AC, convert it to high quality AC that the power company likes. And the power company produces pretty high quality AC. So 240 volts, the right phase with the right signal integrity in terms of harmonics and stuff like that. So that's the job of a good inverter. So when the AC service goes down, this inverter's got nothing to lock onto. And so it shuts down. And so there's, from here on, there's no power being generated. However, suppose it's a bright sunny day and there's a fire. And the fireman comes up and he says, oh, I got a fire on this roof. I'm going to shut off the AC disconnect and the DC disconnect. I'm going to shut off everything in the breakers. I'm going to shut off everything I can. And he gets on the roof. Well, on a sunny day, there is still DC current going through these panels and significant amps. So he's got to deal with the fact that these things are still on. Okay, so this is a relatively, well, I don't know. It's, I think it's still probably more cost effective to do it this way. This is how all the utility grade stuff is done. Okay, I'm going to switch here into PV modules, but before I get into that, I'm going to take a break. So I'm going to take a break right here, and then I'm going to show you an example of a PV array that is used what's called microinverters, and it's from Josh Vogel's workshop. So I'm going to show you a demo of that. Okay, so 10 minutes.
And I'll give you a quick reminder, right out there, go to this area, go to the background, leave the door shop open, and that's the first thing. The door, we'll be back in 10 minutes, and then back.
It's pretty. Although actually the modern one. Just went through all the guys. Months ago, I think why not the mob? So this paragraph talks about this paragraph here is hybrid complex small PV. Why do you see that? Yeah, I just don't know what the cost is. And then hot water stuff is 6,000.
So what is the
process? Yeah, but no. What is this hybrid No, but I'm just saying regular one here. The regular one. No. Yeah, but I I'm doing well. I'm doing well. Yeah.
Okay, back in session here. Part one is over, and we're starting with part two of photovoltaics. It's obvious that solar panels are of interest because otherwise on a nice spring night, I don't think we would have this many people here. So thank you all for coming, and we're going to jump back in. I'm not exactly sure what Steve's doing.
I'm going to drive a demo from here.
Okay.
So I'll try to speak up so people can hear me. But I'm going to guide you through a monitoring system for a photovoltaic array that's on Josh Vogel's workshop. This is a 12-panel array. These are 270-watt Solar World panels. They've got in-phase microinverters. And this is a demonstration of the monitoring system that's associated with this, this series of microinverters. This system is distinguished from the earlier system in that each one of these panels has its own microinverter. So what is produced and is on the rooftop is 240 volts AC that then goes into the service panel. So in this diagram, you see the 12 panels, and the bottom diagram, the bottom of the diagram is due south. So this, you can see that it isn't particularly oriented. It's oriented towards the southeast, which means that it is a little less than optimal than a south facing. However, it's a little cooler, runs a little cooler because more of its sunshine comes in the morning hours. So this is a graph of the power production in the last 7 days. So you can see the hashiness of some of these graphs. That's as clouds go over. I'm going to blow up one of these. This is going to be for today. And you can get an idea of what this looks like. This is power on the vertical axis. This is in watts. This is a 3.2 nameplate kilowatt hour system. And you can see that the power production reaches about 2.5 kilowatts. Today's total, if you look on the right-hand side, I'll move the cursor over, is about 18.6 kilowatt hours. So if my demand was at 15 kilowatt hours, that would be running higher than the demand. This enables you to get the power of the last 7 days, the month to date, over the lifetime, et cetera, et cetera, et cetera. So this tool enables you to understand the power production of the array. And if we look at power production on year to date, what you can see is the envelope. I'm going to actually point to this. So the envelope of the peaks. So if you're looking, this is the first of the year, and this is energy in watt hours, kilowatt hours, in watt hours, I guess. You can see the tops of these peaks come up like this. This is the effect of the sun angle. So the sun is now getting higher and higher in the sky, and you're producing more and more power. During this period of time, if you remember, January had a lot of inversion. So you see this power being knocked down. These are cloudy days. So if you were having to provide power by batteries during this time span, you'd have to, actually have a backup source either through batteries or a generator. This particular period of time, it needed to have a little bit of system repair, and so the system was actually out during this time. And then you can see big troughs here where it was a completely cloudy day, but you can see this general pattern of increasing energy production as time goes on. What this will do is it'll show how power is produced for a given day. This is today. And it starts when there's not much power at all being produced. You can see it grows over time, and you can see the power production as a function of time. You see it blink in and out as clouds go over and then drop off as the day ends. So it gives you a good visualization. If there was a panel that was out, you could tell it. It turns out that the panels that are on the top right-hand corner, these two, are closest to an eave, and those panels don't get quite as much sun. If you look at energy in the past 7 days, you can see that the daily produced energy does vary quite a bit day to day. It's the average energy production over a year's time that you're interested in trying to compute how much energy you get and how much energy you need to meet either a net zero or to, basically you don't want to have too many panels because then you're producing more power than you're consuming. And you could carry it over to the next year, but basically you want to stay under the amount of power that you actually use because there isn't a purchase power agreement or anything like that in place. This is a 3.2 kilowatt array. It's 12 panels. And they're using microinverters. So, okay, let me go back to the other slide. Yeah. One of the characteristics of microinverters is that the energy production of one panel and microinverter is separate and independent from the energy production of the others. So if there's a shadow of some sort that falls across the array, it doesn't affect the power output of the entire array. It affects the power output of that particular panel. But the other panels continue to go on and make their own power. So if you remember that very first slide I showed, if that had been done with separate independent microinverters, then its power production would be very much better once there's a shade on any of the panels. The other big attribute about microinverters is that instead of up to 600 volts DC being on the rooftop, there's only 240 volts AC. And when the power goes down, if the fireman comes along and he shuts off the power, then there isn't any AC power on the roof either. The only power there is relatively low voltage, single panel voltage going into a single inverter. So it's a lot safer. Okay, so we'll revisit that a little later. I'm going to talk about PV modules now. Yeah.
What's the install cost difference for microinverters?
Microinverters are still slightly more expensive. It varies depending upon if you're at the sweet spot of a string array. I mean, if you were doing a utility grade, you wouldn't use I don't think you'd use microinverters. Do you know of any utility systems that have used microinverters?
Yeah, there is some.
There are some?
I can't imagine.
Yeah, but in general, if you've got a big unobstructed roof space, the string inverters are going to be cheaper. If you've got a faceted space with lots of trees or power lines or chimneys or things like that, then your production is going to be very much better with a microinverter system, even though the initial capital cost is going to be higher. Or a DC optimizer, yeah. Yeah.
Well, I'm wondering, so if you, in the older systems you had all solar panels feeding to one inverter, in the microinverter you got multiple inverters. How is the power aggregated before it goes on the grid in the microinverter setup?
Older, newer. I mean, there, as Dave points out, there's actually yet another way of optimizing power with DC optimizers. But to answer your question, the power is the connection of microinverters is all 240 volts, and it's all the phase of that power is matched to the phase of the grid, and what is added is current along that. So you're basically adding the currents of all those.
So each microinverter has the capability of matching to the grid?
Yes, each microinverter does. And if the grid goes down, then each microinverter goes down. And if you've shut off the AC power, then that AC line is down. And the part that's active is the DC line between the microinverter and the panel.
whether it's true or not, warranties are warranties.
Mm-hmm.
No. But most string inverter warranties are 10 years,
Mm-hmm.
but Enphase microinverters are 25 years, which is quite interesting.
Okay.
Now, whether that is reality remains to be seen, but
right. Yeah, the good news on microinverters is there isn't a single point of failure, so you can lose 1 or 2 or 3 microinverters and not lose your whole string. The bad news is that there's many more parts of possible failure, so there's many more things to possibly go wrong. So reliability of the microinverter is essential. It is key to have that microinverter be reliable. Yeah.
Thank you. A lot of technical talk here, and that's a little over my head, but you're talking about warranties of 10 to 25 years, but most people stay in a house 7 years.
Right.
Have you done any studies to see what type of real estate values, how they're affected by having solar?
The best one I've seen came out of California because they had kind of early adoption. You can Google it. It's called something to the effect of California PV home premiums. And there's probably others out there. That's the one I was.
All right. The National Appraisal Association has
National Appraisal Association.
That's a good point, though. Yeah, the comment I've heard from real estate folks that I've talked to on any of this sustainable stuff is the difficulty is comparables. Yeah. How do you find a comp for somebody who's done something, has put in a net zero house or something like that? But also, there is a defined advantage, and the house, one of the houses that I just showed you, sold for far more than I thought was possible. And it was because the buyer had a value set that they saw that roof, the one that had open space for it. And so it was in our neighborhood, and everybody was shaking their head, how'd they get that much for it? So, it's kind of the right house and the right buyer, and it's a little bit more difficult.
The more that's installed, the more it has better.
Okay, so there are 3 or 4 basic types of PV modules. The initial PV modules were monocrystalline silicon, and you can tell them because they're round or almost round pieces of wafer. There's multicrystalline, and it kind of looks like a plaid, almost like look. There's thin film, and they are completely all one color. They don't have the lines on them. There's building integrated photovoltaics. And this was all the rage, still is, I guess, but boy, there's a lot of different alternatives. There's flexible thin sheets. Unisolar pioneered this. There's roof tiles. I'm not real big fan of the roof tiles, but they're there. There's awnings, like we saw with Luminos or shades. And there's a good review of that in Home Power. Okay, this is an eye chart. The only real message I want to get across here is this is efficiency on this axis, and this is time on this axis. And if you look at this, relative efficiencies of photovoltaic panels is not really improving very much over time. So while cost is going down, almost all these technologies, some of the technologies like these guys up here, these are real specialty lab kind of things, or these guys down here, which are organic or trying to use a batch process or a continuous process to make photovoltaic panels. Basically, the kinds of cost reductions you're going to get with photovoltaics is not associated with improved efficiency, which means the roof area that they're going to need is going to remain relatively constant. While the costs may go down, you're still going to need a lot of roof to produce much power. Okay, building integrated photovoltaics for some cool examples. This is another example of this Luminos used as like a patio cover. This is the example of thin film. The thin film panels here and over there. This is a thin film panel. You see how they're all one solid color? They're being used on the side of a building in Europe. Here's a whole facade, a glass curtain wall. It's being done with monocrystalline panels. So they're cladding buildings in Europe with the stuff. Okay, so I'm going to kind of whiz through this because this is really technical, and I'm not really going to go into it too much. I'm going to skip it. I'm just going to show you pictures, I think. Okay, here's a sun power. This is one of the more efficient modules, and this is monocrystalline silicon. These are the ones that have the little round thing. These are the ones that have been out there the longest. This particular brand prides itself as being the most efficient of the panels, and it was like 22%, I think you can get them for. 19 was really pretty high. So that's monocrystalline panels. This is another monocrystalline panel from Solar World. This is an older panel. Solar World is manufactured in Portland. Here are some solar panels that were along a freeway in Europe. So they just, they use the side of the freeway to put in PV panels. Here's a nice small array in Bozeman, Montana. You got a nice roof. I thought that was a pretty nice example. I don't know if he's using microinverters or not on this one, but it was a relatively small house. He had a nice place for it. So, this is just a breakdown of when you go from what you expect to see out of the panel to what you actually see. There's all these derating factors, all these various ways in which you lose energy along the way. So you start out with 1,000 watts per square meter from the sun, and you get an efficiency from the panel itself, and then past the panel, by the time you actually get it into the meter, then you've got all these factors that that eat up some of the efficiency. This is an interesting panel, and it does gain energy from both sides. I don't know if that's a good idea or not. This is this thin film panel. You don't see individual round wafers here. You don't see that plaid pattern. The company in the United States that produces this is First Solar. They're a big producer of thin film technology. The thin film panels tend to be less efficient. They've been out there, and they haven't been out there as long, and so their life is, well, you could argue that maybe their life is less known, but I think there's been a lot of testing on it. Panels have been out there, what, 15 years? Something like that. So it's not like they were out yesterday. They've been out in the field. And First Solar is one of their primary markets is for utility grade solar. So they're aiming to produce panels less expensively. Sort of the holy grail of PV production is to produce panels in a continuous process. So if you could imagine producing PV panels like you do newsprint. So it's all of these panels that I've shown you are batch processes. But if you could use some sort of either an organic process or a thin film process or some way of continually producing PV panels, like you do industrial glass. Industrial glass, you do it in these big rolls. I mean, Nippon sheet glass in Japan, huge, big, wide roll, and this glass is just continuing to run off of this stuff, just continuously. It's an amazing process to watch. When PV panels are made with a continuous process, then the cost will take yet another jump down. But nobody's really got that yet. Okay, this is a flexible laminate. This was pioneered by Unisolar, whose primary market was to go between the ribs on a standing seam metal roof, so you could roll it out on a standing seam roof. It isn't terribly efficient. It does absorb energy in a number of bandwidths, so that's an interesting feature of it. It was also used by a startup in Boise called Novus, and they wrapped it around a light pole and combined it with LED technology and a battery and made basically photovoltaic lights, so street lights. And so that's, they took this kind of flexible solar film and wrapped it around a a pole and generated power that way. This is the shingle. The 62 watts, that's a small amount of power. The number of interconnects on this stuff just must be nuts. But if you wanted to make them look like shingles, you could probably make them look like shingles. You ever done any of that? All right. Okay, so here are the panels. Here's the panels on Josh Vogel's house. You can see one of the guys that was helping us. He decided to get creative about how to work on these. But so this one is has been installed on a metal roof. These are 270 watt Solar World panels, and there's 12 of them. So this was the demo. This is what you saw in the demo. Was this one? So I'm circling back around and talking about microinverters yet again because I'm so keen on microinverters. This Enphase pioneered these microinverters. There's many other companies now that make microinverters, and so there's competition in this space, which is a good thing. So why do you use a microinverter? Well, individual PV module energy is optimized and monitored. So not only is each module another. So if you've got a shadow across a standard string setup, here you get architectural design freedom. You could basically put PV modules in various places and at various times during the day. Some will be shaded and some won't. Of them will get an output that is proportional to how much higher strength sun. So they're expandable and scalable. There's a sweet spot with string cost and what the panels cost and that sort of thing. This scales pretty much linearly with the number of modules. I mean, there's a fixed overhead cost associated with it because you've got to have somebody install them, that sort of thing. But if you wanted 10 modules or 12 modules or 14 modules, whatever, you could do that. There's the fire safety. There's AC rather than DC on the roof. There's the ease of installation. There's a low insurance cost. If you wanted 2 modules, you could do that. You wouldn't need to buy a system with 10 modules or 100 modules or whatever. So you can buy however many modules you think you need. The point of failure, however, with multiple inverters, there's a possibility. If it's a random possibility that an inverter fails, the more you have, then the more likely you're going to see an inverter fail. So why not? Well, you get a higher system cost. So it's $1 per watt compared with 50 cents a watt for a single inverter. So that's just kind of round numbers. But so far, whenever I've tried to size a system, it's been less expensive with single inverters or setup. And reliability, lots of inverters, harsh environment, sitting up possible that they might fail. Speaking of failing, my clicker is no longer working. Okay, so imagine this house or something like it. You've got all kinds of gables, all kinds of shadows. If you had a string inverter or a string system on this, that'd be, you wouldn't do it. You might argue you wouldn't do anything on that house. But you do have a nice area here that you can make use of. And, they've got a big shadow that comes across here. You've got this guy that might come across and cause a shadow. You've got this tree. So if you're dealing with an older home or if you're dealing with a home that's surrounded by trees or has power lines or telephone poles, stuff like that, then microinverters are useful that way. So how does it work? So it's a DC connection to each module. So it's DC between the module and the inverter. It's either 208 or 240 AC connection and a branch circuit to the service panel. And the microinverter shuts down when the AC connection is lost. Lose the AC, it shuts down. So how does it monitor the PV system? There's an AC communication to an envoy. There's a box that talks to each microinverter, and then that is uploaded to the web. And so that's a web-based application. And the thing that does that is called an envoy. So, and the way the communication goes from this box to each one of the microinverters is over the power. So it's a power line communication system. Yeah.
I've got a question for Scott regarding over-the-power communication. Because one of the concerns of the smart grid is the increased radio frequencies from meters, but I've also told that Idaho Power's communication is over the AC line. Can you give us just quickly the overview of how that works?
We've run fiber optics to all of our substations. And so from the substation to the meter, we communicate over the power line. So it's not a radio frequency, it's not, some of the other utilities go up and down on the streets, but ours are communicated securely on our lines that we own between the meter and the substation, and that substation to drop the fiber optics and come back to the power.
Okay, so how long will they last? Enphase says 300-year mean time between failures, which sounds great until you have, 30 of these microinverters. And so then it's only 10 years between failures if it's a random failure rate. And so then you're likely to lose one. In fact, the first guy that I knew that installed them, John Weber, I think he lost 2 or 3 of these. Huh? 2? Okay, on the microinverters from Enphase. So he was kind of unlucky in that way. When we installed them, we had them all come up, so we didn't have any out-of-box failures.
I put quite a few up again.
Yeah?
We really haven't had them fail beyond the first 2 months.
Okay.
If you had a failure, usually you have it right away.
Oh, okay, all right.
Yeah, once they're up and running for a couple of months, they'll probably get it right.
Right. Can you speak about, go ahead.
When you have microinverters, does that imply that there is no DC disconnect, only an AC disconnect?
Yes, that's true. So can you comment, Dave, on other brands of microinverters that have come along?
Oh, man.
Yeah, yeah. Are there things to watch out for? So everybody's got a microinverter. Are there anyone particularly good?
I put some reason solar in there.
And did it well?
But the specifications are pretty incredible.
Okay.
And it's supposedly not fit.
Right, right. So you can always tell the pioneers because they're the ones with arrows in their backs. So.
That's the only ones I've seen probably.
The Chinese ones. Okay. Okay. So, so how long do they last? What does the material supply chain look like? I don't know. I mean, I don't know where the stuff is made. Is Enphase made in the U.S. or are they made in Taiwan or somewhere? Anybody know? Yeah.
Well, some of them are assembled in Canada.
In Canada. Okay. So there's a bunch of questions about microinverters that I don't know the answers to, so maybe I shouldn't ask them. Okay, things to remember. Module voltages are added in series at a constant current. String currents are added in parallel at a constant voltage. High voltage DC exists even at very light levels. So even if the strings are disconnected from the power, there is still high voltage DC on the roof.
It's your highest.
It's your highest voltage. And, considerable amps. So PV voltage goes down as temperature rises. So that's a good thing because the opposite is true. When it's cold, you get better voltage, so you get better power production when it's cold. Yeah.
Yeah, are you just talking about the seasons or are you talking about the panel over time?
I'm talking about how the voltage varies with temperature. So if it gets hot, then the voltage goes down and your power production goes down. If it gets cold, then the voltage goes up. And since power is voltage times current, then power production goes up. And you actually get the best power production on a cold, windy day with the sun shining directly on it. You get good power production.
We've seen above nameplate rated here.
Okay.
I just realized is there a difference between mounting like flat on something and giving air gap and it's cooler?
Well, you know, when you're racking, you're going to get 3 inches on it anyway. You know, and that usually seems to be good enough. We don't pitch them off the roof anymore because you don't get that much gain.
Right.
And your wind loading really goes up.
Oh, you say you need to
They're parallel with the roof.
Yeah.
And that actually applies to anything electrical. Just mainly what they're talking about is at some point, everything's connected with wiring, and the warmer the wires get, the less current flow you have for the same size wire. So the cooler it is, the easier it is for it to flow.
But this really is that loss from voltage really is how it react between them.
So I've got an east roof and a west roof, and I don't have a south roof. So knowing I have an east roof and a west roof, where would I put the solar hot water and where would I put the PV? Put the PV on the east and the hot water on the west. Yeah.
I put that PV on the east and west.
You would.
Yeah.
You wouldn't.
Only lose 25% on the south. That's the worst case scenario.
So you do it either one.
Yeah, we do generally east-west. You gain a little more. The east will outperform the west, and the reason it will is cooler usually in the morning.
Okay, so we'll ask Scott. When would you like to have the power? In the morning or the afternoon? The west, yeah. Yeah. That matches the load. That latches the load. So see. Okay, more to remember, when the grid goes down, so does the grid-tied PV array. Doesn't matter if it's a microinverter or a string inverter. If you've got a grid-tied array, power goes down, you don't have any power either. It comes as a real disappointment to some people. Max PV array voltage occurs on a cold, windy, sunny, well, that'd have to be winter, but cold, windy day. Spring. PV arrays are active power sources regardless of whether they are connected to the rest of the system. So even with a microinverter, the panel connected to the microinverter, that panel is hot, even though there's no power to or from the microinverter, because the PV panel itself is producing voltage on the panel. It's lower voltage than a string, but it's still a single panel voltage.
Open voltage is higher than connected.
Yeah. Okay. Yeah.
Increased fire danger. I mean, if you've got something that falls on the panel in a windstorm.
And there, yeah. Yeah. That being said, I haven't had problems, but it's there, yeah. It happens.
If there are a lot of PV panels on lots of roofs like there are in California, then the question is, when there's a fire due to another cause, then are the fire guys, you know, are you not creating, I mean, how do you avoid creating a hazard to the firemen?
We don't have it primarily because every inverter has a GFCI, and it's 1 amp, and it's going to go pretty fast.
It's going to go. Okay, voltage and currents and PV can kill you. Electricity is best left to electricians. Dave's still here, so I guess it's, you know, I didn't kill him yet, so. Okay, and then there's some resources. So that's what I have. Any follow-up questions? Yeah.
I have a consumer question.
Okay.
So you have the list of resources you kind of snap in my camera so they can. But where could I go to find out about the performance of different companies that put on solar panels? You know, maybe I've talked to one, but I want to compare it.
Right.
Where would I go to find information like that?
Anybody want to handle that one?
Well, okay, I'm in the business, okay?
With conflict of interest.
I know most of the people in the business. They're, you know, and really, they're pretty good guys. So I would recommend find somebody you can get along and get some reference letters. Go call people. Everybody will send you somebody. You know, the systems are the systems. There's not much difference between A and B in reality.
What about things like installation costs, which would be independent of the actual product?
Well, the reality is, it's not like general construction. Your labor costs are smaller in PV compared to material costs than general construction. So that the labor is going to affect the cost of that system smaller. So there's not going to be a very wide range of prices. So it primarily, I just recommend, look, get a few people, get some references.
So you've heard from a provider. It sounds a lot like the rule of three, Make sure you have 3 bids from your contractors and choose the one that fits you best.
Maybe a little out of context right now, but I wonder if Steve has comparing, as we were discussing earlier, using a solar thermal and a gas water heater, for doing water augmentation versus PV cells and like a heat pump water heater that's electric in nature. And how you feel about those?
Yeah. Okay. So suppose the task is to provide domestic hot water. Okay. So you start out and you say, well, I could do it with natural gas. So now you have a low capital cost because natural gas water heaters don't cost a huge amount. And the running cost is the cost of natural gas. So another alternative to produce hot water is electrical. Now, electrical water heaters are slightly less expensive than natural gas water heaters, so you get a lower initial cost. But the running cost for electricity is higher than that of natural gas. So, you pay for it in the long run. Suppose you're on propane. Well, propane's really expensive. So now that's an even more expensive way of heating hot water than it is either electrical or natural gas. So now you say, okay, well, I really want to do solar. I want to do solar of one kind. Well, there's a variety of ways of doing that. One way is to put in a conventional solar hot water system, and we'll call that X. Second way is to put in a PV system, use resistant heating in an electric tank. So now you have an electric tank, which is the cheapest tank, and a PV system. And you use PV energy. You get the advantage of net metering, and you use electrical energy to then heat hot water. So your capital costs are the electric water heater, which you may have already, and a PV array. Now, the catch with the PV array is not, well, there's two questions. One is, how much is that PV array going to cost? And the second one is, how much roof area is that PV going to take? So you can attack both of those questions if you go a step further and you say, well, there's heat pump technology. I can use a heat pump. And the heat pump is a air to water heat pump. Now, suppose you add that to the system and combine it in with PV. So now what you've got is the capital cost of the electric water heater and the capital cost of the heat pump and the capital cost of the PV array. Now the PV array is going to be a lot smaller because now you're using the advantage of a heat pump to reduce the size of the PV array. So your roof area problem goes down some. But your capital cost goes up because now you have to, well, I don't know if it goes up or not. You use less PV panels, but now you have to buy the water source, the air source, water heating heat pump. So if that isn't confusing enough, then let's talk about scale. So if you're one person, then it may be that the scale argues, in fact, in favor of just PV panels, resistance heating, and electric tank. If you were trying to heat a college dormitory or if you were trying to heat a motel, you certainly wouldn't use PV panels and a heat pump. I think you would use solar hot water because you have a large system, and the capital cost of a large system is amortized over a whole lot of users. So part of the answer to the question is scalability. And the sweet spot for solar hot water, for just conventional plumbing solar hot water, is a family of about 5. So you've got 3 kids, couple with 3 boys, for instance, in that photo. That's a pretty good answer there. But if there's 2 people, then it's less clear whether or not you couldn't do better with a PV array. So have I penciled any of these out? No, I haven't. The only thing I've penciled out is the cost of producing power with a PV array versus the cost of producing power with solar hot water. And at $4 an installed watt, for a 4 or 5 person family, it's still somewhat cheaper to use solar hot water than it is PV. That's without using this heat pump idea.
Well, John Weber penciled it out.
Yeah.
For one guy, but John Weber is not like any person.
Yes, that's true. Go ahead.
And he was definitely way ahead with the one person. Don't do solar hot water.
And I believe that. One person.
John doesn't operate like him.
Yeah. Yeah. So if people are interested in it, there's a product called Solar Bandit that uses a couple of PV things, and they advertise that they don't even connect to the grid, which I'm not sure I'm in favor of. But there are products that are aimed at doing just that. And I am not up on penciling them out for all the cases. So mostly because I don't know what the cost of heat pumps are. Yeah.
When you look at all the suppliers, the manufacturers of PV arrays out there, are there a top 5? I heard mentioned like First Solar, Solar World, Sun Power. Are there a couple more, others to stay away from?
Well, I don't have the experience base to know.
I will tell you a little.
Yeah. Why don't you, let this guy talk about it.
The reality, if you're a tier 1, and if you get utility scale, they want to talk about bankability. Okay, will the thing be a good module? So a tier 1 module is, look, it's got this much backing, you have this much experience. But here's reality. Most tier 1 modules are made. Now this is whether it's China, Korea, US. It's made, assembled by about 3 different companies. That's it. To some extent, it's apples and apples, okay? You can get bad modules from China, and you can get bad modules from the U.S. And so I'm really kind of more interested in the equipment they're using in assembly. But the other equation is we do a lot of solar world because it's a U.S.-made module, and we kind of like the idea of the money staying here. That's really
are they very similar on most of the?
I wouldn't count on any company less than 25-year warranty. But it's really not necessary to some extent. There are, if you're talking a monocrystalline module, I mean, man, it's been around since 54. It's a pretty good track record. I don't need the same brand module, anything, to fix a bad module. I can get any module if the voltage matches. Okay? I can do it outside voltage, but I'm going to affect production then. But to some extent, can you count on any company being around 25 years for, yeah, exactly. And boy, I love that.
Yeah, that's an interesting point. So my background was in disk drives, and everybody's got a disk drive in their computer. And disk drive industry, there were something like, over the period of time that I was in the industry, there was something like 500 companies making disk drives. And if you take disk drives as an aggregate, they lost money as an industry. So you take everybody that was in disk drive business. So the idea that companies, lots of companies start new ideas and lots of them fail, and yet produce a value that's almost invaluable to the country, is something that's lost on a lot of people. I mean, you're going to have a lot of failures with high-tech stuff. And so if you point to one or two or half a dozen or dozens of companies that have come and gone, if you look at the overall advance in reduction of price and the ability to form an industry, it pales in the comparison to those few companies that have gone by the wayside. So it's just kind of a little soapbox to end things with. Any other questions? Yeah.
Someone was telling me about sort of fire access requirements when you install solar on
Yeah.
the roof. Can you elaborate on what those are?
Yeah. So in some municipalities, there's a couple of things that are not so far done in Idaho. There is, in Oregon, for instance, you have to have access to the array from, I believe, 3 sides. There are zones that you've got to stay out of. You can't put the solar panels to the edge of the roof. You can't put them on the very crown of the roof or on the ridge line of the roof. You've got to leave a certain amount of space there, and I believe either on 1 or 2 edges. So there are special requirements. For instance, that house that you saw at Cuna, I don't think you'd be able to do that in Oregon. California, there were some municipalities that required a DC or even an AC disconnect up on the roof. There isn't a requirement for microinverters to have a rooftop disconnect here. So there's some discussion about whether or not the breaker could serve as the AC or the DC disconnect means or the AC disconnect means. And we chose to put one in ahead of the service panel, even though you could argue that the breaker itself might be an AC disconnect. So. Oh, they did. Okay. So how far do they have to be set back?
Get an electrical permit, put one in, you can also have to get building.
Okay. All right.
You got to get through that.
Oh, good to know. Good to know.
Yeah.
Well, you can see it from the firefighter's point of view, definitely.
Talking about that, a couple of systems I've seen, exposure string, string converters, 1 day converter, and so there's risk.
No, there's some labeling requirements. Yeah, there's some definite labeling requirements still that are there. So you don't do away with them all.
And you can have multiple disconnects required on a battery backup system. Because if you think about when a fireman comes up to a house, if they want to do a pull meter, normally that kills power to the house. In a battery backup system, all that does is switch the inverter over to pull the batteries and everything is still on the inside. So sometimes the electrical inspectors are looking for multiple disconnects in there to shut down the inverters to keep them on. You can see multiple disconnects, class, AC, DC, it can get confusing.
You just need one E-stop button, the fire button.
And that's really what a DC is. It's just switching auxiliary contact in the inverter to shut off that DC.
Thank you very much for coming.
Thank you all.
Yeah.